Here's a related rates problem. We have a ladder which is 17 feet long, leaning against the wall of a house. It begins sliding down the house so that the top of the ladder is moving down the wall at a rate of 1.5 feet per second. How fast is the foot of the ladder moving away from the base of the house when the foot of the ladder is located 8 feet from the base? So here we have a drawing of the situation. We have the ladder, which has a constant length of 17 feet, and it's leaning against the house. And we'll label the vertical distance from the ground to the top of the ladder as y, and the horizontal distance from the base of the ladder, or the foot of the ladder, to the foot of the house as x. Now what we have here, the top of the ladder is moving down the wall at a rate of 1.5 feet per second. So we can express this as dy dt equals 1.5 feet per second. How fast is the foot of the ladder moving away from the base of the house when the foot of the ladder is located 8 feet from the base? So what we're asking is, what is dx dt when x, the foot of the ladder, is equal to 8 feet? So what we need to do here is we need to find an equation which is true at any time. So at any time, we have the following. Because we have a right triangle with the ladder and the wall of the house and the ground, we assume there's a right angle here. We can use the Pythagorean theorem. So we have x squared plus y squared equals 17 squared, or 289. Now we can differentiate both sides implicitly with respect to time. So if we differentiate both sides with respect to time, we have 2x times x prime plus 2y times y prime is equal to the derivative of a constant, which is 0. So we can divide everything by 2, and we have x prime, which is really dx dt. I'm just shortening the notation here, plus y prime is equal to 0. Now what we want to find out is, what is x prime when x is 8? So we have x prime that we need to find. We have x. We know that y prime is 1.5, and that's going to be a negative number because the y is actually changing at a negative rate. So we put a negative 1.5 for dy dt. Now to find x prime, we need to find what x is when y is, when we need to find out what y is when x is 8. So looking at the right triangle, when x is 8, we have an 8 and 17 hypotenuse here. The third side, y, can be found by using the Pythagorean theorem, and by using that theorem we find that y will be 15 when x is 8. So substituting those numbers in, we have x is 8, x prime is what we wish to find, y is going to be 15, and y prime is going to be negative 1.5 feet per second, and that's going to equal 0. So what we're going to have here is 8x prime equals, now we're going to put this on the other side and write it as 15 times positive 1.5, and then we're going to divide by 8 to get 15 times 1.5 divided by 8. And so that'll be our answer for the rate of change. And we can simplify that answer using a calculator.